All right, J Rider 4 and Wise Nubian. Um, you know, you guys have been having a lot of statistics thrown at you by people, and they throw out these statistics like they are, laws of the universe or something. So I thought I would talk to you guys about statistics. I like statistics. I avoided it for years because I didn't think I was going to like it, man. I heard that they were boring. I heard that it was a difficult class, that it was a boring class, and I just had a kind of a misconception of how statistics worked. But then I had to learn some statistics for this job I took. So I took a class in statistics. I was blown away. Um, it's remarkable, man. You see laws of nature going through statistics. But enough of that. I want to show you a book. It's called How to Lie with Statistics by Daryl Huff. Let's see. Illustrated by yeah. How to Lie with Statistics. This is a great book. This shows you how people will take statistics and pick meaningless ones and juggle them around and take something that should be a way to find out what's true and like distort it. All kinds of from very simple techniques to like really sneaky ones. Um, that's the story. Great book, How to Lie with Statistics. Um, then I want to give you a kind of a few questions you could ask that will blow people out of the water to kind of question their statistics. And most people won't know this. They're just going to look in the book and they're going to say, oh, well, 10% blah, 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 blah. But here's the thing. In statistics, what they call the population is the total number of people that you're studying. Um, like, say, the population of the United States, right? You want to know something about them. The reason you use statistics is it's too time consuming and too expensive to actually go talk to everybody in the United States. You couldn't even find them all. To find out what you need to know. That's too expensive. So what they do is they invented statistics so that you could talk to a smaller group of people and then draw conclusions about the larger group mathematically. So the whole entire group you want to study is the population, and the small group that you actually do study is called the sample. So you have sample and population. Um, and if there does appear to be a relationship between something that you discover, like say uh, smoking and lung cancer, uh, how strong that relationship is, how solid that relationship is called the correlation. Say one thing is correlated, yeah, correlated, huh? Correlated. You say one thing is correlated to another. Now, what nobody tells you if they're just throwing statistics at you is you can have a strong correlation where the two are obviously strongly related, or you could have a weak correlation where you can hardly even see that there's any relationship at all. Um, and the letter that they use, the statistic they use to express how strong a correlation is, they just use the letter R. So R is the correlation. And if you have strong R, strong correlation, you'll have I think a big R. Weak correlation, you'll have a small r. So anyway, some of the questions you could ask when these guys throw it at you. First of all, you want to know how they conducted the study. I mean, what did they use? Surveys? Did they interview people? What was the method they used to get their information? What were the tools they used to gather the information? Did they use census data? Or did they, like I said, did they use surveys? Did they do personal interviews? That's called the methodology, the data collection techniques. And methodology sort of includes those data collection techniques and then the way you do the math. So just if you ask them what was their methodology, unless these people have really studied those statistics with any kind of deep understanding, they're not going to know. It stops them in their tracks. Um, Another one is just ask them, well, what was the population that was being studied? You know, was it all the people in the United States? Was it limited to certain cities? Was it a subgroup? Subculture? What was the population that was being studied? And here's the key: how big was the sample? How many people did they actually talk to? I mean, because obviously if you've got the whole United States with I don't know how many people we have now, man. It's the population's way. But if you have a 100 million people and you talk to one guy, if your sample is one guy, you can't have any reliability of results. However, if you talk to 50,000 people, now maybe you could start to draw some, some good conclusions about the group. So ask them how big the sample is. And how big the sample is real key. Just mathematically, you have to have a big enough sample to make anything. So ask them how big the sample was. That ought to throw them off. And like I say, if they don't know these answers, man, that means that, they didn't really read the original research paper. They didn't read the research paper. So that's the story there. What data collection techniques did they use? And what was their methodology in general? What data collection techniques did they use? What population were they studying, and how large was the population? How many people? And what population was it? How large was their sample? Was it one person or 1,000 people? And how strong was the correlation that they claimed to have discovered? Was it a strong correlation or a weak correlation? What was the R? That's a story. Now, here's why I want to tell you now why statistics blew me away. The way our minds work is like really linear. Now, what I'm going to explain to you explains why people lose so much money gambling. I'll tell you, man, after taking a statistics course, I will never gamble. Our mind just doesn't understand the huge numbers that are possible. Here's an example. Let's say you have 10 books and you want to put them on the shelf. 10 books, everybody, just 10 books, right? And a shelf. And, you could put the books up there in a certain order. Now, it was this example that made me realize why they invented the Dewey Decimal System in libraries. So 10 books. Okay, you could put up in any order you want. How many different ways do you guys think there are of putting those 10 books up there? How many possible combinations of the 10 books? Yeah, how many different ways can you mix those books up and put them up there on that shelf? What do you think? My first thought was like 100, maybe. Most people will say about 100. Some people will say there's like 50 or 20. If you do the math, you guys, those simple 10 books, the number of ways that you can put them up on the shelf, the number of orders you could pick, is 3,628,800. That's how many different ways you can arrange those books on the shelf. It's phenomenal. Real quick, the way you figure that problem out is you sit there with your books and you figure, well, the first of the 10 books, there's 10 different slots I can put it into. So there's 10 possibilities. Now I got 9 books left. Now for each of those 10 possibilities, my next book, there are now 9 places left that I could put those books in, because I used up one place to put the first book in, and now there's 10 more. There's 9 more places. So there's 9 ways that I can put the next book up. Then you go, once again, you have 8 books left. You pick up the book number 8 and you say, well, how many places can I put it on the shelf? And you realize that you've only got 8 slots left, so there are 8 ways you can put that up. So basically, there's 10 ways to do the first book, 9 ways to do the next book, 8 ways to do the next book, 7, 6, 5, 4, 3. So the answer is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you multiply that out, you get 3,628,800 ways to put those 10 books up on the shelf. Our minds just don't do that, man. Our minds work like real linearly. We're close to the earth on that stuff, man. And gambling, one of the things you study in statistics are what are the odds that I'll get a full house? What are the odds that I'll get a straight? What are the odds that I'll get a flush? And when you do the math on those things, it's like this, man. The casinos have got this rigged. I mean, they're rich. They are not going to lose, man. The numbers are on their side. That's a story. Let me know if you guys want to know more about statistics, man. I dig them. I didn't think I would, and I was blown away. That's the story. For any details, you can leave a comment or respond by video or send an email or whatever you want. Okay, guys, take it easy.